Hello, class, and welcome to September 18th. This is Monday, and I'm just pulling up the Curriculum Mac and assignment list for you just to make sure we're all on the same page with where we're at. So this document is linked in your Moodle page, and we are in Module 4, where we talk about elements and compounds. You can read Chapter 2, Section 3 in your textbook, and then watch my lesson video on it, take and submitting your lesson notes, completing the weekly discussion. And then we have a couple of fun lab simulations to do that I want to walk you through today. So again, we are in week 4, module 4 this week, and these assignments and activities will take us from Monday, September 18th through Sunday, September 24th, which again, when all of your assignments are due. So bear with me, I'm going to pull up our course page in Moodle, and then I want to take us through some of the lab simulations that you guys will be working on. Okay. For your patience here. So let's go into our chemistry page in Moodle. Let's scroll down to week 4, module 4, September 18th through September 24th. Take a look at that section in your textbook. Watch the lesson video. Please take and submit your notes and upload them, paying close attention to those questions at the end. There's going to be some examples of how to determine elements and compounds. Please complete the Module 4 discussion, and your Module 4 discussion will test your knowledge of classifying each of the following as an element, a compound, or a mixture, and providing reasonings for each. And these discussions are a great way to give you guys sample problems and then help each other solve them. So feel free as you're working through that, to ask someone to explain it a little bit more, or I'm kind of confused on this, and either a classmate may be able to help you out, or I will be watching the discussion this week to respond to any questions. You also know to message me or email me through Moodle or directly to my email if you do have any questions this week. Okay, so taking us back into Module 4, we have 2 lab activity simulations on states of matter and gas properties. I'm going to save those for the end. You'll have a quiz this module. Join this weekly call or look at our class YouTube page for the recording. Continue to work on this lab activity, the physical and chemical changes. And a couple of you have responded to this. I think I've set it up so you can reply more than once. So feel free to do this a couple of times. Let me just make sure the settings are set up so you guys can reply more than once. Yeah, so you should be able to do this activity more than once. So feel free to do it more than once, just as a way to practice working through whether we have a physical or a chemical change. Okay, so that is due October 1st. So I kind of give you the whole unit 2 to work on that activity, the physical and chemical change activity. Then I think I'll jump into our gas properties simulation. We'll go through this one first, and then we'll take you through your next simulation. So these will be kind of virtual labs for you to do this week. You'll need to enter in this website into a browser. It takes you through a Colorado kind of virtual lab simulation exercise. And if you have any questions on how to get there, let me know, but this should be how you'll want to enter it into your browser. When you get there, once the site loads, you'll search and launch the gas properties simulation. You will add gas molecules to the box and click play. So let's search for simulations, and the best way to search, I'm just going to search for gas properties. And it automatically will give you a list of simulations relating to gas properties, and you'll want to click the one that says gas properties under that simulations tab. So I'm going to go ahead and click the link right away. So right at the top, and it'll launch an interactive simulation. You can do it in the ideal setting for now, and I'll show you what we're going to do. So if you can kind of keep the document open next to the website. And for these questions, you're going to add gas molecules to the container. And to do that, you can click whichever color you want, and then you'll move this up and down to add gas molecules to the container. So you're adding gas molecules to an enclosed container, and you'll notice you can change the temperature of the container. You can hold things constant in the container, and then we'll see how the pressure changes. So you see kind of the pressure in atmospheres of the chamber with these gas particles being added. You'll notice as you add more gas to the chamber, pressure continues to rise because you're adding gas to an enclosed space. Click on this orange arrow to restart it. But let's just do maybe 1, 2, 3, 4, 5 pumps of gas. Again, you can choose your gas. I chose the blue. You can choose red. They probably stand for different elements. So, and then it'll take you through kind of 3 simple scenarios or questions. And you'll need to understand what the word direct means and what the word indirect means. And it kind of gives you a little hint here. A direct relationship between 2 variables means that when one goes up, the other goes up as well, or when one goes down, the other goes down. So a direct relationship means, for example, if we increase the temperature, the pressure will increase. An inverse or indirect relationship between 2 variables means that when one variable goes up, the other goes down, and vice versa. So what are we talking about here? Let's go through our scenario 1, keeping volume constant. So let's go back to our scenario. Let's keep volume constant. That means that the volume in the gas chamber, or this square, the metal box, will not change. So it says, keeping volume constant, see what happens to the pressure when you change the temperature by heating or cooling the box of gas molecules. Is the relationship between temperature and pressure direct or inverse or indirect? You can use the word inverse or indirect the same way. Again, a direct relationship will mean that if we increase the temperature, the pressure in the box will increase. And an indirect or inverse relationship will mean if the temperature increases, the pressure will decrease. And we describe that as a T equals 1 over P. So let's see what happens. We're keeping volume constant, and we're going to see what happens to the pressure when we change the temperature. So temperature is in Kelvin. It's at 300 right now. Let's go to 27. So right now, the pressure is about 15.5. What happens when we lower the temperature to 27 degrees? So we've lowered the temperature to 27. I think, oops, we want to keep that volume constant. Pressure is still kind of remain the same. Let's add cold and see if that changes anything. Let's go to negative 36. Ooh, now we see the pressure changing a little bit. Let's make it even more cold. Negative 62 degrees Celsius. What do you notice happening to the pressure? As we're lowering the temperature, as temperature is decreasing, let's make it a little colder. What happens to the pressure? The pressure is going down. So we have a decrease in temperature equals a decrease in pressure. They're both going the same way, so we call that a direct relationship. Well, let's just test it. Let's add some heat. We're at, you can see, negative 44 degrees, with the pressure starting to increase. Let's add some more heat. Let's go up to 1 degree Celsius. The pressure is continuing to rise. Let's go up to 57 degrees Celsius. We're increasing the pressure again. So we increase the temperature and the pressure is increasing. So both are increasing together and both are decreasing together. So if we go back to our worksheet, is the relationship between temperature and pressure direct or inverse? It's a direct relationship because when we moved the temperature down, the pressure decreased. And when we moved the temperature up, the pressure is increased. So that's a direct relationship. See if you can do that on your own for scenarios in questions 2 and 3. And then try to see, can you describe the relationships between temperature, pressure, and volume of a gas in a quick and dirty, quick and easy formula using the variables temperature for T, pressure for P, and volume for V. And if your answer contains a reciprocal, like 1 over that, please use algebra to break all the variables to the baseline. See if you can work on that on your own, and I'll provide you with some solutions at the end of the week. So do the best you can. You could even maybe search for a formula that combines these 3 variables together, and you can look up that. So have fun with that simulation. And then there's one more simulation to look at too. Let's go back to our chemistry course. And you should be able to upload the gas properties simulation here. And now let's go through the states of matter simulation. So we have a completing the lab activity, the states of matter simulation. Let's pull this one up. So a states of matter simulation, this one takes you through kind of a similar simulation. And there's a little kind of introduction section. This one is a little more self-explanatory and has you work through it on your own. Please print this out in a PDF, because that will keep everything looking nice. And then maybe your printed copy, you can even write in and upload pictures. So we're going to the link for a simulation as shown there. It's done by the same kind of Colorado education system, and it will take you through kind of looking on the states window. And I'm actually gonna have you guys work through this one on your own, because the steps are pretty easy to follow. If you get stuck up on a step, do the best you can and then move on to the next step. But this one is really nice because it takes you through kind of parts at a time, and kind of working your way through it. It's a little bit longer, so give yourself, a good maybe hour or 2 to do this one. And probably the other one will only take 45 minutes. And just a reminder too, if you are a full-time student with Amazing Grace, we're supposed to give you between 45 and 50 minutes of work to do every day. So that's why this week is a little bit bulkier, because I want to start to kind of give you guys more work to fill up your days with, reading your textbook, taking the notes, the quizzes, watching my lecture videos. That'll take you a good 2 or 3 days. And then the lab activities or simulations hopefully will fill up your final days of the week as well. So again, this simulation is the states of matter simulation. It will take you to a similar website. You'll work through the states first, and I'm just going to have you guys work through it on your own, because I think the steps are actually pretty good to describe. But if you get caught up on anything or have questions, let me know for that one. But it'll probably work best to maybe print that out and then walk through the simulation on your computer as you're working through it. And feel free to do the fillable if you guys are, good with that. If you like to do that better, do it however you best see fit. And then you have a simple quiz at the end on elements and compounds. So hopefully that gives you a good introduction for this week. Again, as usual, contact me with any questions. I get your things graded and back to you. I'm going to try to always get things graded and back to you by Friday for the previous week's material, just so you guys know how you are doing in the course. I'm really impressed with the work you're putting into this. Keep up the great work. It's been a fun class. I've enjoyed reading the discussions and getting to know you that way. So take care, everyone. Have a good rest of your day, and we'll see you next week.